Hi, my name's Jody Chapman, and I'm here with Dr. Ricardo Gonzalez-Rothi to give you an inside look into the pleura and the pleural space. What is the pleura exactly?
The pleura is a continuous membrane of cells that folds over onto itself at the apex and at the base of each lung.
What is the pleural space?
Well, the pleural space is a potential space that's between the parietal pleura that lines the inside of the chest wall and the visceral pleura that lines the lungs as the two pleural membranes fold upon themselves.
What are the functions of the pleura and the pleural space?
The pleural space helps regulate the pressure inside and outside the lungs during breathing. It is thought that the fluid in the space provides lubrication for the pleural surfaces on the lungs and the chest wall as they slide against each other during the breathing cycle.
How much fluid is in the pleural space?
This visceral space is estimated to hold between 8 and 10 milliliters of fluid per side in an average-sized adult man. So it's not very much fluid. And under normal circumstances, that amount is held at a pretty fairly constant volume.
What is pleural fluid? What kind of substances would you find in it normally?
Pleural fluid is a very clear plasma filtrate, if you will, which originates from the small capillaries in the chest wall, and it contains small solutes like sodium, chloride, bicarbonate, also contains glucose, as well as a small amounts of protein, including albumin. And when compared with serum, pleural fluid actually has near equivalent concentrations of glucose, but it has slightly higher concentrations of albumin and bicarbonate. In fact, the increased bicarbonate concentration results in an alkalotic pH of about 7.6 under normal conditions. Pleural fluid also contains macrophages, lymphocytes, and mesothelial cells that exfoliate from the pleura, and these are also found in pleural fluid in low numbers under normal circumstances, generally under 1,700 cells per cubic millimeter.
What are the mechanics of the pleural space? How does it work?
The fluid in the pleural space provides mechanical coupling between the two pleural surfaces, and it actually allows instantaneous transmission of perpendicular forces between them.
What exactly do you mean by mechanical coupling?
The mechanism of mechanical coupling is similar to that which occurs, say, when a glass coaster sticks to the bottom of a slightly damp glass. You have the thin film of fluid between the two smooth surfaces, and this creates a partial vacuum that forces the two surfaces to cling to one another, yet allows the two surfaces to slide against each other. A similar situation occurs between the two pleural surfaces during breathing, as the lungs expand and contract within the chest cavity.
Where does pleural fluid come from?
For a very long time we weren't exactly certain how this came about, but during breathing the recoil of the lungs creates a negative pressure in the pleural space, especially towards the apex of the lung, and plasma filtrate is drawn by a pressure gradient from the subpleural capillaries in the chest wall, and this fluid passes through the mesothelial cells of the parietal pleura into the pleural space by what are called Starling or pressure-related forces. So the volume of fluid in the pleural space is maintained in equilibrium under normal circumstances, such that fluid inflow is approximate to fluid absorption from the pleural space.
How is pleural fluid absorbed?
Pleural fluid is primarily absorbed through the mesothelial cell layer of the visceral pleura. Fluid also exits the space through these microscopic unidirectional valves that are in the parietal pleura, and they're known as the lymphatic stoma. And these lymphatic stoma are really only found on the parietal pleura. The stoma stretch during inspiration and allow cells and cell debris and other particulate products through. It's been recently discovered that fluid absorption from the pleural space also occurs as a result of what's called electrolyte coupling through the mesothelial surfaces of both the parietal pleura and the visceral pleura.
We've gone over normal pleural fluid mechanics. When you have too much fluid, it's called a pleural effusion. What mechanics are broken when there's a pleural effusion?
The thin film of fluid between the parietal and visceral pleural surfaces creates a partial vacuum of negative pressure, which forces the surfaces of the pleura to cling to one another. If you have too much fluid under pathologic circumstances, this disrupts the mechanical coupling between the chest wall and the lung, and the pleural surfaces no longer cling together. So the lung actually pulls away from the chest wall. And this increased fluid in the thoracic cavity reduces the vital capacity of the lung to fully expand during inspiration. And this can lead to shortness of breath and, on occasion, a feeling of fullness in the chest. The lung tissue, in turn, becomes compressed by the effusion, causing atelectasis of the alveoli and reduced ventilation to the areas of the lung that are being compressed.
Could you give me some examples of where you would clinically see a pleural effusion?
One mechanism of pleural effusion formation is that's caused by conditions that increase hydrostatic pressure. In the case of heart failure, you have increased left ventricular and atrial pressures, which cause a back pressure on the capillaries in the lung, and therefore you get interstitial pulmonary flooding. And this causes fluid movement and accumulation by transudation into the pleural space. The nature of this fluid is that it's a very low protein content, and as such, it's usually referred to as a transudate.
Another example is when there's a tumor in the lung or chest wall.
That's another mechanism of pathologic formation of pleural effusions, and pleural effusion can form as a result of impairment of the lymphatic drainage. A tumor in the lung or in the chest wall can mechanically obstruct the thoracic lymphatics, causing a pleural fluid accumulation by decreasing the rate of absorption of pleural fluid that normally occurs.
In cases of pneumonia, you commonly see pleural effusions. What causes an effusion in that case?
Inflammation can increase the permeability or the leakiness of the lung and the chest wall capillaries as a result of inflammation and or infection. So you're right, a classic example of this mechanism of pleural fluid formation is parapneumonic effusion in the setting of an infectious pneumonia.
You can have an effusion when there's an unexpandable or trapped lung. What is a trapped lung?
Certain conditions can cause the lung to become unexpandable, if you will, in which case the lung physically pulls away from the chest wall, causing an imbalance of pressure, which favors increased filtration of fluid into the pleural space and formation of a pathologic pleural effusion. You can have inflammatory, infectious, or neoplastic changes which can encase the lung surface, leading to a trapped lung with subsequent formation of pleural effusion.
There are cases when there's a pleural effusion and the pleural mechanics are fine, nothing's wrong with them. Where is that fluid coming from?
Yeah, that's correct. There are certain circumstances in which the fluid formation within the thorax and the absorption are intact. There's nothing wrong, but the mechanism of pleural effusion formation can occur as a result of excess fluid entry via what I would say are non-physiologic routes. And a typical example of this can be seen when peritoneal acidic fluid enters the pleural space via defects in the diaphragm in the setting of liver disease such as cirrhosis. I think looking at these mechanisms from the different perspectives that we've talked about really helps conceptualize how different disease processes can affect pleural fluid formation, and I think it helps the clinician conceptualize the whole process better.